10.2, where we're going to continue looking at solving equations with pan balances. First thing, starting out with algebraic equations. Remember, algebraic equations are number sentences that have variables or letters that represent something that is unknown that we typically want to try to solve it for. So the first one says if you double me and add 6, you get 20. The key word here is double. What does that word double? It means times 2. So if we're taking a look at our examples, looking at times 2, it should be the first one or the second one. But then it says add 6 to get 20. So it should match up right there. If you add 5 to me, you get 0. Pretty simple one, matching up down here. If you double me, add 4, subtract 4, and then divide by 2, you'll get 9. That's going to match up with the first one. Using the order of operations because they wanted you to do all this first and then divide by 2 to get 9. And last but not least, if you take half of me and triple the result, you get 30. The idea of half is dividing by 2, triple to multiply by 3, so leaving us with that option. Your math journal, your math message is solving the pan balances in each of the figures. So it says one block weighs as much as how many balls? Well, you can see that we have 2 blocks right here, so we have to split our group into 2. So this one can match up with this, and this can match up with that. So each is left with 2. One ball weighs as how many marbles? 1, 2, 3, 4, 5. 5 marbles. Pretty easy to start out with. Today we're going to get a little bit more complex where you have to solve multiple things before you can get your final answer. Like here's an example. One block weighs as much as 2 balls. So a block is equal to 2 balls. And we'll make the balls a little bit bigger than our marbles. And then it says one ball is equal as much as 5 marbles. So we'll make those smaller. The question says, therefore, one block is equal to how many marbles? Well, we could think that there are 5 marbles for 1. So we could say that there are 5 marbles here, and there are 5 marbles for this one to get us a total answer of 10. Taking a look at another example, just to give you an idea of how to solve something. I remember yesterday we have to make sure that both sides of the balance are equal at all times. If you do something to one side, you have to do it to the other side as well. So here we had learned back here that how many paper clips it took. We know that it's about 31 paper clips that is going to be equal to a protractor, so they can be in exchange for each other. So now I can easily figure out what this ruler is going to be equal to, because if there are 31 paper clips on this side and 70 on this side, we can take 31 paper clips away from both sides, and that would leave us, and that's just showing you kind of what it's doing. Another example is adding clips to balance the plans as well, something that I will have stations available that you can actually manipulate and move these things around and kind of figure them out as well. But if we're taking a look at our math journal, especially on page 336, you may have to do one step before you can do the next step. So like on number 3, we want to know one block weighs as how many marbles. Well, if we took a look at our example, we have one block is equal to all these marbles, but we also have a coin. So the first thing we need to do is find out more information about this coin. And this second pan balance is giving aid or help to us with that. So it said that one coin is equal to 1, 2, 3, 4, 5, 6, 7 marbles. So if I cross off 7 marbles here, and if I cross off 7 here, Okay, 7 marbles is equal to a coin, so I can cross off the coin. Now all I have left is 1 block and 5, 10, 11, 12, 13 marbles. So 13 marbles would go here, and 1 coin weighs as much as we had said 7 marbles. Taking a look at another example, 1 block weighs as much as how many marbles? Remember, these are not marbles, these are balls, okay? So we can't answer this question quite yet, so let's go ahead and look at an example of another pan balance. It says we want to know 1 ball weighs as how many marbles? We have 2 here, so that means we have to divide it into 2 equal groups to figure out for 1 ball. So that this can be represented by this ball or those marbles, and that can be represented there. If we were to count them out, 1, 2, 3, 4, 5 marbles. So if going back to our question, what we're trying to answer, 1 block weighs is how many marbles. We know that each ball is worth 5. So we have 5, 10, 15, 20, 25, 30 marbles. Looking at another example, number 5, we want to know 1 block weighs as much as how many marbles. Can we answer that based off of here? We absolutely can. So that's 2, 4, 6, 8, 9 marbles. Taking a look at the second part, it says 1 ball weighs as how many marbles? Well, starting out, there is a block on this side, there's a block on that side, so we can cross those out to get started. Now we have 1 block, and we know that 1 block is going to be equal to 9 marbles. So we can replace this or think of this as 9 marbles instead. Now it says 1 ball is equal to how many marbles? We have 3 balls and 9 marbles, so we have to split this into 3 equal groups, which is going to give us 3 in each group. You're going to be finishing page 337 as well. Make sure that you're using both pan balances. There are 2 pan balances for every single problem that you need to be answering. Sometimes all your information is here to help you with the next one. Sometimes you can't get your information here and you need to do the second pan balance first. 338 is exact same thing. Page 339 in your math journal is just taking a look at line graphs. Remember, line graphs always give a title. They give us information about what it is going to be about. They also have subtitles. This one is telling us time, and this is temperature. Remember, we always have equal increments, and it will give us more details as well. If I were to try to read this at 1 p.m., the temperature was 74 degrees. Remember, we often like to use line graphs to show trends. Trends are things that happen over time. Down below we have a line plot where an X is equal to a representation of 1. So how many pounds was in week 1? 1. How many pounds were in week 6? 3. Make sure you're answering those questions as well. The big idea is to really make sure that your pan balances are always equal on both sides. Sometimes you have to take a couple extra steps before you can get with the answer that you are looking for. If you follow those rules, you will be successful in today's lesson.